Thomas Gredig. I'm a nanotechnology experimentalist in the physics department at California State University, Long Beach. You're probably familiar with solar cells like the one in this calculator. This is an inorganic solar cell made of silicon. Turns out silicon is very expensive to produce, and also it breaks very easily. I would like to make solar cells out of organic molecules. Organic molecules are carbon-based, similar to the molecules in this plant. The advantage is that they're inexpensive to produce and that they're also flexible. In my lab, we make novel organic thin films that one day may be used to make enhanced solar cells. Please join me on a tour of my lab. Currently, we are making thin films of an organic molecule called phthalocyanine. You may not have heard of phthalocyanine, but in fact, it's a very strong dye. It's what makes your blue jeans blue. It's very exciting to understand that the same molecule can be used to produce electricity. But there's a lot of physics that needs to be done before these solar cells go into a store. In fact, it's possible that we may discover other useful properties in these thin films that we haven't even imagined yet. The first thing we had to do was learn how to prepare thin films of phthalocyanine. The students in my lab have investigated the conditions required to prepare films with the surface features we wanted. Here is Matt, one of the undergraduate students in my group, preparing a set of thin films for testing. We start with a substrate wafer and coat it with a very, very thin layer of gold. Then we place the wafer in an organic thermal evaporator and we add a crucible of phthalocyanine. The solid phthalocyanine is heated to 350 degrees Celsius and it sublimates, filling the chamber with phthalocyanine gas molecules. Some of the molecules adhere to the gold. A thin film of phthalocyanine is formed that is only a few nanometers thick. If you were to stack 1,000 of these films on top of each other, it would barely have the thickness of a single hair. We discovered that by changing the conditions, we could change the surface structure, or grain size, of phthalocyanine. This photo shows the surfaces we can produce, from tiny grains all the way up to these elongated shapes. Next, we need to measure the properties of the thin films. When light hits a solar cell, electrons are excited and eventually produce the electrical current that powers your device. When light hits our organic thin films, electrons are also excited, but sometimes, due to interactions with neighboring atoms, these excited electrons are trapped and do not flow freely. We are trying to learn as much as we can about these trap states, so we can produce efficient solar cells. Here you can see my graduate students at work. In this setup, we shine a laser at one of the thin films we have made and observe the current produced. By analyzing the data, we get an indication of the behavior of electrons and characterize their trap states. You might be interested in why I study thin films. I always wanted to be an explorer. As a child, I would sit at lunch with my father and plan which uncharted parts of the earth I could explore. Maybe the central parts of the Sahara or some corners of Australia. As I grew up, I learned that these last unexplored places were mapped by other people, and there simply weren't any unexplored places left on Earth. But with physics, I found a way to explore new worlds that no one has ever seen. Tiny worlds I create in my lab that we can explore right here at CSU Long Beach. Students play an important role in my research. I love the diversity here at CSULB. I like to see the different perspectives my students use to approach problems. So I try to step back and let the students work a little on their own to see what they will come up with. They learn from me, but I try to learn from them as well. It is fun to push in new directions, to take small, cautious steps like an explorer would, hoping to find the treasure just around the next corner. We are explorers. Maybe you are an explorer too. Maybe you would like to join us and study physics here at Cal State Long Beach.